session. So this is the first tutorial session of the network analysis course, whose instructor is Professor Tapas Kumar Bhattacharya sir from IIT Kharagpur, and I am PMRF research scholar here in IIT Bombay in the Department of Energy Science and Engineering. So in this tutorial session, we will solve few of the questions related to the network analysis, also related to some concept related to KVL, KCL and all. So before moving forward, so you should we will go from the basics only, so we will see that how kind of questions are related and how you are solving the assignments as well. So this is the first question I am putting forward related to related to the charge entering a certain event. So we have to find out what is the current at 1 millisecond, 6 millisecond and 10 millisecond. I'm giving few minutes to solve this question. Just let me know when you have done. Okay, let me give the solution. I've got the few answers. Let me give some of the answers for this. So if you see that, okay, what is the current in 1 millisecond? So if you're drawing from the slope, if you see the curve, the QT versus T curve, so the same will be starting from that I is equal to dq by dt. So if you see that what is the slope correctly, so that is 30 minus 0 minus 2 minus 0, that is come out to it both terms, that a coulomb is also millicoulomb, time is also in the millisecond, so you will find out that this is a current is 15 amps. So the current at 1 millisecond is actually 15 amps. If you see the current at second option, if you see the current at 6 millisecond, so the rate of change of charge is actually zero because the Q is constant. If the Q is constant, the current is zero. So the current is zero at the 6 millisecond. So if you see that from the 2 to 8 millisecond, the current is overall zero because the Q is constant. If you see the current at the 10 millisecond, so for finding that you have to check the slope. So if you find out the slope, what will happen that it is 0 minus 30 divided by 12 minus 8. That will come out to be minus 30 divided by 12 minus 8, that is 4. If you cut it out to 15, that is come out to minus 7.5 amps. So the current at 1 millisecond just come out to 15 amps, and also at a 6 millisecond it is come out to be uh, 0, and if you see from at the 10 millisecond it will come out to be minus 7.5. Okay, so moving ahead, we will see the second question. The second question is related to there is some powers are given, that P1, P2, P4 and P5. So you have to find out what is the power received or delivered by the element 3. So I'm giving you a few minutes to solve this question. Let me know when you have done. So if you see the solution part, so if you see there are five elements are there. First and second, third, fourth, fifth elements are there. The power which is drawn, absorbed or the delivered, it is given in this P1 and 1, 2. Okay, and also same with this P4 and P5. So if you see the first and second element, the P1 and P2. So if you sum up that 60 minus point minus 0.205, it is coming negative. If you see it, so it means that it is actually absorbing power. Same with if you see the other branches at P4 and the P5, that is summed up in a positive, that is 75 volts. So it is actually delivering. So if you consider a negative as absorbing and positive as a delivering. So if you sum it up, what it come out to be for the P1 and P2, it is come out to be minus 145 watt. Okay, So if you see that there are some power which is being absorbed in the one branch, 75 watt is being delivered in one branch. So that extra, that is actually from where it is coming. So it will come from the P3 branch. So that is actually equal to 145 watt minus 75 watt. It is coming out to be 70 watt. So 70 watt being delivered from the element 3. Okay, are you getting my point? So there is a concept that if you're considering one as a negative as a absorbing, so positive you have to consider as a delivery. Okay. Okay. So moving ahead to the next problem. Here in this question you have to find out the current and the power what is being absorbed by the each element. Okay, there are three elements are given: the current source, voltage source, and there are two elements are there, that is black box is there. So you have to tell me that what is being power absorbed by the each element. Okay, I'm giving you a few minutes to solve this question. Just let me know if you have done. So I hope you have solved this question. Let me give you a solution for this. If you see there are current sources, there are voltage and there are two elements which is being shown. So if you see there a current source which is giving the current as 8 amps, which is going in the one element, that is where the voltage is showing as a plus minus 9 volt, that is considered as element A. So the 2 ampere is going inside of that. So other, if you see the 3 volt system, that is element B, there the current it will go 6 amp because the KCL have to be followed. Okay. So the 8 ampere will be delivered, 2 amps is going in element A, so 6 amps will go into element B. So the power which is delivered by the element A or taken by the element A, it is coming out to be 9 multiplied by 2, it is 18 watt. Okay. So I am considering absorbing as a positive, so going inside of that. So if you see the element B, so the power which is being absorbed is a 6 multiplied by 3, it is going to the 18 watt. Okay. So if you see the element C, here the power is what is being delivered. Let's consider this as a positive or negative. Just write it down what is the power. 8 multiplied by 9, it is coming out to 72 watt. But when you are considering positive as a absorbing, so the negative will be termed as a delivery. So here the minus 72 watt come into the system. So if you see the element D, it is coming out to be 6 multiplied by 6 power, that is 6 volt is across and 6 ampere is going into it. So it will come out to be 36 watt. Okay. So the power which is being absorbed by the element A and B is 18 watt. By C which is being delivered is minus it is 72 watt. And what is being absorbed here in the 6 volt across 6 volt is 36 watt. Okay. Have you got my point? Okay, let moving forward. So I'm giving you next question. So this is question where you have to find out the what is value of V naught I naught in the circuit. Okay, I'm giving you a few minutes to solve this question. Let me know if you have any doubt. Okay, let me give the solution of this question. If you see, there is a circuit which is given which have this 9 amp source and 2 ohm resistors, and the current which is flowing in, there is a current source also I 0 by 4, and the voltage drop here across the atom, it is given as a V 0. Okay, so if you see the trying to solve in this question, so always follow the method of which I follow actually. If you see, there is a node which is given here, and the current which is coming here I1, and the current going out is I2, and the current which is leaving at I3. Okay, so minus I1 for current which is coming into the system, and I2 and I3 which is current going out of it. Okay, so here the current, if you see that the same we will apply into the circuit, that minus 9 which is coming into the plus V 0 by 2 plus I 0 by 4 plus V 0 by 8. Why V 0 by 2? Because the current voltage drop which coming across the 8 ohm, it will appear across the 2 ohm as well. Plus I 0 by 4 because it is leaving the node, plus V 0 by 8 by the same method. Okay, because if you see, there are two unknowns are there, V 0 I 0, but there are one equation, so I need one more equation, that is V 0 is equal to 2 times I 0, that is a voltage drop across a 2 ohm resistor. What will happen, that minus 9 plus I 0, because we are putting the V 0 value to I 0 into the equation 1, that is I 0 plus I 0 by 4 plus I 0 by 2. If you sum up, it will come out with 3 on I 0 by 2 is equal to 9. So I 0 will be equal to 6 amps. So similarly, voltage, if you find out V output is equal to 2 times of I 0, that is 2 multiplied by 6 is equal to the 12 volt. Okay. So this may you can find out the V naught I naught of this circuit. So I'm moving forward to the next question. Okay. So this is answer 12 volt and 6 amps. So this is a question here in which we have to find out the R equivalent of the circuit. So try to find out the R equivalent of the circuit. I hope you have got the answer for this. So let me explain that how to find out the R equivalent. So if you see that there is a voltage, if you see the current values of the R which is there in the series and the parallel systems, if you see there is a, I'm considering the two nodes A and B in between two parallel resistors R1 and R2. So the here, how you find out that this is the actually the in the parallel fashion or in the series fashion. So I is actually being divided in the parallel circuit. It can be equally if the resistors are equal. If it is unequally, also if the resistances or impedances are not equal. Okay. So if they are divided, if you see the voltages that node across AB, that if across the VR1 is equal to VR2 is equal to V. Okay. Same way, if you see the current that is I1 and I2, their summation is equal to I. So if you see the series fashion, so R1 and R2, here the current which is going into the R1 is equal to the current which is going to the R2. So current is being constant and the voltage which appear across the R1 is I times of R1 and V2 across it is I times of R2. So summation of the voltages is equal to V1 plus V2 is equal to IR1 plus IR2. So for this question, if you are going to find out the what is the R equivalent of the system, so if you see the 20 ohm and the 5 ohm, here the two nodes are common, so they are in the parallel. So the what is the R equivalent? 20 multiplied by 5 divided by 25 is equal to 4 ohms. Okay. So and 1 ohm is in series. So 4 ohm plus 1 ohm is coming out to be 5 ohms. So this 5 ohm is in parallel with the 20 ohm again. So this again is equal to 20 multiplied by 5 divided by 25 is equal to 4 ohms. Again, if you see, it is in series with the 2 ohm. So 4 ohm per 2 ohm is 6 ohm. So this 6 ohms node, if you say that the two nodes are common with the 9 ohms as well at 18 ohm. So 9 ohm, 18 ohm and 6 ohm is in parallel. So the how to find out the R equivalent of this? So if you see 1 upon 6 plus 1 upon 9 plus 1 upon 18 is equal to 1 upon R equivalent. It will come out to be 3 ohms. Okay. So the R equivalent of the system will come out to 3 ohm. But there are 16 ohm is also there. So 16 ohm plus 3 ohm it is equal to the 19 ohm. So correct answer of this question is the 19 ohm. Okay. So moving forward to the next question. So in this question you have to find out the R, A, B and I. Okay. Just let me know if you have any doubt. I hope you have solved this question. Let me give the solution of this question. So there is one method to solve this question, that the star and delta conversion. Okay, if you can see that RA, RB and RC is in delta format. So if you're converting from the delta to star connection, that a small RA, small RB and small RC. So in the first sense, if you are converting from delta to star, so RA will be come out to be RA RB divided by RA plus RB plus RC. Same with if you see the RB come out to be RA RC divided by RA plus RB plus RC. Okay. So if you converting same from the RC, that come out to be RA RC divided by RA RB plus RC. So if you see for the star to delta, star, that is small RA, small RB, small RC, converting to delta, capital RA, capital RB, capital RC. So it will come out to be RA is equal to small RA plus small RB, RC plus RA plus RC divided by RB. Same with the RB, if you see RA plus RB plus RA RB divided by RC. Same for the RC, capital RC, if you see RB plus RC plus RB RC divided by RA. So this is methodology to be followed for the conversion from the delta to star. So if you see in this question, that is 30 ohm, 50 ohm, 20 ohm, they are in the delta format. So how to convert into the star? So star, if you see in between 30 ohm 20 ohm, it come out to be 20 multiplied by 30 divided by 20 plus 30 plus 50. It is 600 divided by 100, 6 ohms. Same if you between the 30 ohms and 50 ohms, that is 30 multiplied by 50 divided by 100. It will come out to be 15 ohm. Same for the 20 ohm and 50 ohm, it will come out to be 10 ohm. So if you add this, if you see it convert into a star, those 24 ohms, 6 ohms, it will come in the series, there is 30 ohms, and 10 ohm and 10 ohm, it will come in the series, that is 20 ohms, and in series with the 15 ohms. So if you see the overall circuit, how it will form, that will come into the 36 ohms in parallel with the 20 ohm, in series with the 15 ohm. So overall, how much it will become? It will become, if you see here, the 40 ohm. When you add with the 13 ohm, it will come out to be 40 ohm. So how much current it will flow? 240 divided by 40 is equal to 6 amps. So the RAB equivalent will be 40 ohms, and the current which is flowing into the system is 6 amps. So moving forward to the next question. So this is a question related to, there are 4 circuits are given. So you have to find out which voltages will appear across this. Okay, the which voltage appear across the terminals A and B is 7 volt. Okay, I'm giving you 5 minutes to solve this question. Just let me know if you have written it out. I hope you have solved the question. Let me give the solution for this. If you see the voltage across the VAB, first question, move forward with the terminals. If you see from the 8 node, if you move into the seeing the 5 volt, the first come with the negative terminal. So connect the negative terminal 5 volt with the A node. So similarly the positive terminal of the 5 volt is connected to the negative positive terminal of the 3 volt. Similarly, the positive terminal 1 volt is connected. Okay. So for summing up, move from the node to the first sign which comes. So it is coming -5 plus 3 plus 1 is equal to -1. Okay. So the overall voltage across the VAB will appear -1. So the minus is coming first. Okay. Plus. So the sign which you will show, it is 1 volt. Similarly with the circuit B, moving forward, that is plus -5 volt plus -3 volt plus -1 volt. Okay, so the overall the voltage come across there, it is 9 volt. Similarly, if you go for the C option C, it will come to be -5 plus 3 plus -1. It will come out to be -3 volt. Okay, moving to the next part, that is coming out to be +5 plus 3 -1. It is coming to 7 volt. So option D is actually correct. Okay. So coming to the next question, here the question is related to the number of branches in node. Please try to solve this question and let me know if you have any doubt. across a particular node, you have to find out the you have to make a reference voltage at a one node so that you can find out the voltage at another node. So in the center, if you see that the element, suppose I'm grounding the in between the terminal at a 0 volt, so VB minus 0 is equal to the minus 1 volt, so VB will be come out to be minus 1 volt. Similarly, if you come to the VC, C terminal, that is voltage VC minus 0 is equal to minus 1 volt. So the voltage across the C terminal, it will come out to be minus 1. Okay. So for finding the current across the inductor, you have to find out, you have to apply the KCL across the terminal A. Okay. So what I have told in before also, the KCL is summation of I is equal to 0, and also you have to assume that what are the if the current is coming into the node, it will be negative. It is going out, it will come out to be positive. Okay. So for finding the voltage at the terminal A and applying the KCL, so VA minus VB, VB is minus 1 volt. So VA minus 1 volt divided by 1 ohm is actually the current flowing across this branch. Similarly, when you see at the terminal C, that is a VA minus 1 divided by J1, that is the current it will flow, and you can directly consider I2. I2 is going out of the node, so it is considered as a positive. Minus 1. Minus 1 in between, if you see the 1 angle 0 current is coming into the node, so it is minus 1. So VA plus 1 plus I2 minus 1 is equal to 0. So plus 1 minus 1 get cancel out. So VA is equal to minus I2. Similarly, if you find, because here the two equations, two variables, two unknowns are there, so we need one more equation. So if you see the branch which consider the inductor J1, so VA minus 1 is equal to I2 times of J1. So VA plus 1 is equal to I2 times of J1. So from here you can see that VA is equal to I2 J1 minus 1, but I2 is minus VA. Okay, so you can directly fit the I2 is equal to minus A. So VA is equal to minus I2 plus 1 is equal to I2 J1. So I2 1 plus J is equal to 1. So I2 is equal to 1 upon 1 plus J. So correct answer is 1 upon 1 plus J. You can consider in the phasor also 1 upon 1 plus J, 1 upon root 2 angle minus 45 degree. Okay. Moving to the next question. This is the next question. I am giving you a few minutes to solve this question. Just let me know if you have any doubt. So let me give the solution for this question. So if you see that, suppose I am taking a one circuit where the 3 volt is given and we have different resistance are there. So if you see the R equivalent of this network, so the current which is going out of this voltage source, the same current will come into this voltage source. Okay. So the current which is out of the system, that to the R equivalent, will same current will come out into the voltage source. So the same concept we will apply here as well. So this circuit which is considering the VB and VD node and different R and minus 10 volt is there. So the current which is going into this network, the same current will come out of this network. Okay. How much current it will go? That is equal to voltage VA minus VB is given, that is 6 volt. So the I will be equal to VA minus VB divided by 2 ohm, that is 6 volt divided by 2 ohm. That will come out to be 3 amps. Okay. So VC minus VD is equal to no, because the 3 amps is going out of this into this network, so 3 amps will come out of this network. So the total current, if you see their current source is also 2 amps, so 2 amps plus 3 amps will go out of this network across the 1 ohm. And the VC, which is a voltage at this node, the same voltage is appear across this node as well. So the VC minus VD is equal to minus 5 multiplied by, why minus 5? Because the current is going opposite direction. Okay. In the voltage which have considered the PC is a positive term, but it is going into that, so it is equal to minus 5 volt. Similarly, if you finding out the VD minus VC, it will come out to be 5 amps multiplied by 1 ohm, that is 5 volt. Okay. So the voltage across the VD, that VC minus VD is equal to minus 5 volt. Okay. So moving ahead, so if you find out this question, if you try to solve this. Okay, let me give the solution for this question. So I will give the basic only. So you have to solve this question that if you see the all the resistances are in additive of 1 ohm. Okay. So this R which is in parallel, then in some series, then whole the system is in parallel, then it is series with R, then it is actually followed. So always remember that when the two resistances are equal, so just half it in when they are in parallel. So R in parallel, that is R by 2, compared with this adding with the R, that is 3R by 2. 3R by 2 again become half, that will become 3R by 4. 3R by 4 when multiplied by R, 3R by 4, let me find it out. That is 3 by 7R. 3 by 7R is actually half. You have to do 3R by 7 and half yearly 3 by 14, then again in summation with the again r, it will come out to be 14 17 by 3 something, you can find it out. So based upon that, the a by 5, a will come out to be some of the value. Okay, just you have to equalize that. In parallel it will become half, when you add it will become summation. Okay, so this is a question related to one practical current source, how to representation actually. So I'm giving few minutes to solve this question. Just let me know if you got the solution. Okay, let me explain this question for you. That if you see the practical current sources, actually they have the current sources, they have the resistances in parallel. Okay, so the resistance is parallel. So if you see the ideal voltage sources, the ideal voltage sources having a voltage source in series. So practical current sources having the resistance in parallel, correct, practical voltage sources having the resistance in series. But if you see that if for the ideal voltage source, there is no voltage across after this voltage source, no series resistance, and same with the current source, there is a no resistance in the parallel. Okay, so here the option, the resistance in series with an ideal current source, false. B option, resistance in parallel with the ideal current, that is true. B option is correct, and resistance parallel with the ideal current, C is actually false. Okay, moving ahead to the next problem. Try to solve this question. Okay, let me explain this question for you. So what is telling that 10 ohm 10 volt battery with an internal resistance of 1 ohm is connected across the nonlinear road whose VI characteristic is given. Current delivered by the battery is. So in this question, the 10 ohm battery, 10 volt battery is in series with the 1 ohm. So if you consider the nonlinear load whose voltage across the terminal is V. So the V will be equal to 10 minus I times of R, that is 1 ohm. So V plus I is equal to actually come out to be 10. Okay. So you got the one equation as V plus I is equal to 10. Second equation you got 7I plus is equal to V square plus 2V. Try to solve it. Both the equation you will find out here one quadratic equation. You will find out two V values and two I values. So based upon that, you will find out what is value of V and I. Okay. Try to solve this question. So let me give you a hint because the time constant is there. So there are three nodes are there. So what you have to do, because the voltage are given, so you just have to find out apply the KCL at the different nodes and find out the value of R. Okay. So try to solve. If you have any doubt, just let me know. I will try to clear it in the next class. Similarly, you have to find out the current across this 2 kilo ohms. So here also, if you see that the Wheatstone base was formed, okay. So in between C and D, no current will flow across the 2 kilo ohms. Applying the concept of the Wheatstone base, okay. Similarly, this question is also similar to that. V plus I is equal to 100. So V, if you see that V is appearing across the 1 ohm also, so V is equal to I. So put it there in the equation, V is equal to I. So 2I is equal to 100, I is equal to 50. 50 amps. Okay, the current through the I ohm is equal to 1 ohm is equal to actually 50 amps. Okay, so this is all from my side. Actually, there are different questions we have solved, different things we have seen. So in the next lecture also try to solve the questions as much as possible and try to find out what if there is having any doubt, just let me know in the next class. Okay, thank you all. Thank you for attending this lecture.